All right, this is Algebra 2, Lesson 6.4, and everyone's favorite, right? Solving word problems. Oh, yeah. All right, and we're going to solve word problems using systems of equations. So if you remember back to Algebra 1, we did these aspects back in Algebra 1, and we're here now to refresh our memory of those. Would have developed it a little bit more completely in Algebra 1, but hopefully we can refresh your memory and get you on track to doing word problems. You might say, oh, I hate word problems. Yeah, well, you need to get over that, really. You have to have a positive perspective, otherwise you're going to make them even more difficult. If you say to yourself, well, I can't do word problems. Well, yes, you can. And there are some techniques that we're going to show you today and remind you of that will enable you to do word problems. So have a positive mindset. Believe that you can solve them because you can. And that's half the battle. All right, let's get rolling. Solving word problems using systems. So number one, when possible, use a chart. All right, use a chart, right? When possible, use a chart. In other words, anytime you can use a chart, use a chart. There are some word problems, and if we get to it at the end of the lesson, you'll see where no chart can be used, but whenever you can, use a chart. All right, A, use the formula. Use the formula to determine the columns. So the formula is going to allow you to determine the columns of the chart. All right, if you remember, this is a key. This is just a help. You've got this chart and you've got boxes you have to fill in. Well, you should fill in the variables first. Fill in the variables first. It's going to take up some of your boxes. That's a good thing. You're going to have less things to fill in, and that's good. That is good. C. Let's see, I'm going to drop this down here at this point. C. The equations will come from the columns that contain the variables. Again, we'll look at all this by example here in just a moment, but just setting some things up. The equations will come from the columns that contain the variables. Okay, we can do that. All right, and let me remind you, this is key here, the two types of equations. Two types of equations. Well, you can have total equations, or you can have, and I'm going to write in green here, comparison equations. Total equations or comparison equations. All right, each one comes with a template. So if you'll look right below here, look at the template for the total equation. Right, the template for the total equation is right here. It's always the first plus the second equals the total. If there would be three variables, then it would be the first plus the second plus the third equals the total. That's a total equation. How do you get a total? You add things up, you sum them. So look, this is the template for all the total equations. If it's a total equation, it's going to look like that. All right, that's doable. And then note for a comparison equation. In other words, instead of giving you an equation that involves summing or total, they're going to compare the things. Questions like this. Bob is 8 years older than Jill. Okay, that's a comparison, right? That's a comparison. One car was moving 30 miles per hour faster than the other car. That's a comparison. That's a comparison. All right, and with a comparison equation, the template is always set the two equal to each other. Set the first equal to the second. Now, they're not quite equal. So let me again give you the example. All right, one car is moving 30 miles per hour faster, let's say, than the second car. The first car is moving 30 miles per hour faster than the second car. Now, you would have already set up something like this. Now, don't fill this in. I'm just trying to get you to think. You would have called the first car X, and you would have called the second car Y. So you set them equal to each other. Now, remember, this is the first car, and we'll do all this in example. Don't do this in your notes. I'm just trying to get you to think. All right? So you got the first car on the left and the second car on the right. And again, you read the problem. It says the first car is traveling 30 miles per hour faster than the second car. And I like to write faster there, and you can put slower here. So look to the right here. It says add or subtract the indicated value, that's the 30 miles per hour, from the correct side to make it equal. Look, if this one is slower, it's slower by how much? 30. How do you make them equal? Add the 30. And by the way, if you don't like adding the 30 to that side, you could subtract the 30 from that side, from the faster one to make it equal to the slower one. That's the idea, and that's what we're doing in a comparison equation. So again, I'll show that to you in a moment here as we do an actual problem. All right, let me get rid of the rest of all this. I keep hitting my keyboard. What a pain. All right, there we go. Okay, so look, this is how you set up all word problems. When possible, use chart, right? Use the formula to determine the columns. Fill in the variables first. When the equations, the equations will come from the columns with the variables in it, and you got two possibilities on the equations. It's going to be a total, or it's going to be a comparison. All right, so let's get to an actual problem here. Let's get to an actual problem. So here we go. Two cars are 100 miles apart and heading toward each other at the same time. Uh-oh, that should be a they. All right, let's fix that. They pass in 1 hour where the second car was traveling 4 miles per hour faster than the other car. How fast was each going? All right, we've got to start off with a formula. So you have to look at this and say, what am I dealing with? I'm dealing with distance. I'm dealing with a speed. I'm dealing with time. And hopefully those three things cause you to think of the formula distance equals rate times time. In our formulas, I like to flip it though. I like to say rate times time equals distance. Rate times time equals distance. Okay, so that's our formula. So notice now how the formula gives us our chart. So our formula gives us our chart. Because I need a rate column, I need a time column, and I need a distance column. All right, and so they're there. Notice something else I like to do in my charts and try to get you to do is to include an equal column. That's an important column, and that's going to help us in our chart, and you'll see that in just a little bit. Just takes a second to stick in there. Stick in an equal column. It really does make life easier, and you'll see why in just a moment. All right, so now we're getting going. All right, next thing you want to do is you want to label your rows. All right, so our columns are labeled by the formula. We want to label our rows. You look back at the problem. What's it talking about? Two cars. There's no other designation given, so I'm just going to call them car 1, car 2. That's all I really have. Okay, if you go back now and look, we have now made a chart. We've used the formula to make the columns, all right? And we have labeled the rows B. Fill in the variables first. That's what we want to do. The variables will always come from the question. How fast was each going? Okay. How fast? Is that a rate, a time, or a distance? Well, it's not a time, and it's not a distance. It's a rate. We'll call the first car's rate X and the second car's rate Y. All right, look at that. We only have 4 blanks to go. This is pretty easy. Okay, we're going to look back into the problem and try to find time or distance to fill in the chart. So we've got 4 blanks to go. Look back into the problem. See if you can find any indication of time or distance. So you read through and you come to the part where it says, oh, the same time. Right? They head toward each other at the same time. And they pass 1 hour in 1 hour. Okay. So they leave at the same time and they pass in 1 hour. How long was the first car traveling? 1 hour. How long was the second car traveling? 1 hour. Okay, great. We have 2 blocks, 4 of the 6 filled in. We only have 2 left. All right. Why do I have the equal signs here? I have the equal signs there because the rate times the time equals the distance. Now, students mistakenly want to stick 100 here and 100 there, and that's wrong. You don't want to do that because the cars are 100 miles apart. Maybe the first car travels, no, I keep hitting that keyboard, sorry. Maybe the first car travels 40 miles and the second would have traveled 60. Maybe the first travels 55 and the second 45. Maybe the first travels 20 miles and the other travels 80. All right? So we don't know the distance of the cars. But we can fill in the distance by doing the rate times the time. X times 1 is X. I'm going to stick 1X just for emphasis on this problem. And Y times 1 is 1Y. Okay, chart's finished. All right, on we go. Let's go back and look at our helps here. The equations, look at C here, the equations will come from the columns that contain the variables. Okay, so we've got variables in the rate column and we got variables in the distance column. Okay, I'm going to do the distance column first. And I like to label these equations. This is the distance equation. So we have a distance equation. And you're going to ask yourself, is this a total or is it a comparison? Well, you got to look back at the problem. The thing that they tell us is the two cars are 100 miles apart. So listen, again, the first car may travel 20, the other would travel 80. 20 plus 80 is 100. Maybe the first traveled 30, the other would travel 70. 30 plus 70 is 100. Maybe the first traveled 49, the other would travel 51. 49 plus 51 is 100. This is a total equation. Therefore, then, we are going to use our total template. First plus the second equals the total. In this case, it's the first car. So you go back to your chart now. Now remember, we're in the distance column. What is the distance of car 1? It's X. What is the distance of car 2? Looking at your chart, it's Y, right? And looking at the problem, what's the total distance? It's 100 miles. Okay. Distance formula is done. Let's go back, find the other variable column. It is in the rates, so therefore we're going to have a rate equation. And again, you're going to ask yourself, is the rate equation a total or is it a comparison? Is it a total or is it a comparison? All right, look back at the problem. The second car was traveling 4 miles per hour faster. 4 miles per hour faster. Is that a total or is that a comparison? That is a comparison. What was the comparison template? First equals second. Okay, remember, we are doing a rates right now. What is the rate of the first car? It's X. So I'm going to put X for the first car. What is the rate of the second? Look back at your chart. Rate of the second is Y. We stick Y. Now, they're not truly equal. So again, I'm going to go back and I'm going to use one more label. It says the second car was traveling 4 miles per hour faster. So I'm going to put under here faster. It's faster. So what do I do with that 4 to make them equal? It's already going faster. Now, some people already know what to do. They already know that they can go -4 and make it work. Okay? If you can't do that, you can play with just any numbers you want. You could say, okay, the first one is going 50, and this one's got to be going 4 miles an hour faster. That's 54. How do I make 50 equal 54? Take away 4 from the 54. These numbers don't matter. You can pick any numbers you want. You're just using it to figure out what to do with this 4. Okay? Now I will say this, just as easily as I took 4 away from the right, I could add 4 to the left, right? You can add 4 to the slower one to make it equal. But that's it. We now have our 2 equations and we're in great shape. Now, you have to finish the problem. All right, all we've done now is gotten the 2 equations. Now we got to say, oh, this is a system of equations. And this is what you should be thinking. So what are the different ways you can solve a system of equations? And I hope you're going through them in your mind. Number 1, you can graph it, not the most efficient. Number 2, you can use substitution. Number 3, you can use the addition method. Number 4, you can use matrices. So you're going to look at it and say, all right, this problem lends itself to what methodology? In my estimation, I'm going to say the substitution method, because look, this equation is already solved for the x variable. Okay, substitution then, where the x is in the first equation, we'll sub that in. So now I'm going to sub in my y minus 4. Go ahead and solve this equation, right? So what do we end up with? 2y equals 104 and y equals 52. Now, it's always important to know what the 52 is. Go to your charts. 52 is the rate of car 2. So 52 miles per hour is the second car. Whoops, second car. All right. Now, how would you get the first car? Well, this one you can do in your head. But if not, you would use the first equation. Now subbing in the 52 for the y. And notice how you get 48 miles per hour is this first car. And that's it. We've got it. We did it. All right. We did a word problem. Woo! Awesome. All right. They're not that hard. We can do this. All right. Let's go on to the back of your notes there. Let's do the next. All right. Here's our next problem, number 3. John invests so much in an account with a 10% interest rate and 100 less in an account that yields 12%. If the total annual interest is $605.10, how much did he invest in each account? Okay, so you're going to have to think back and think of, all right, what was the formula for this type of interest problem? Do you remember it? All right, hopefully you remember I equals P times R times T. And again, we're going to do it backwards. We're going to go P times R times T equals I. P times R times T equals I. Okay, that shows us our columns, doesn't it? And therefore now we have a chart that looks like that, right? Principal times rate times time equals interest. All right, just a quick reminder, what is the principal? That's the amount invested or the amount borrowed, the principal. The amount you invest or the amount you borrow. Rate is the interest rate, an annual, usually interest rate, might be called the APR, and percents are always in what form in formulas, and hopefully you're thinking decimal form. Time, all right, it's going to be in years usually, 1 year, 2 years, 8 years, whatever. All right, and then interest, what is the interest? Interest is extra money you earn for investing or extra money you have to pay when borrowing, right? Extra money you earn when investing, extra money you have to pay when borrowing. All right, let's go ahead and label our chart here, our rows. So in this one, we really don't have a lot to go on. We just have account 1 and account 2. And that's all we can do there. Okay, do you remember what you fill in first in your chart? I hope you remember. It's the variable column. Makes life easier. How much did he invest? How much did he invest? I'm looking at the red, right? How much did he invest in each account? So what are we looking for? Is that a rate? Is that a time, is that an interest? Is that a principal? The amount you invest is the principal. So X and Y. All right, awesome. 2 blocks down, 6 to go. All right, so now you're looking into your word problem and you're trying to find a blank. All right, if you start reading, you come across this 10%. Oh, that's a rate. I can put that in. Remember, decimal form, 0.10 or just 0.1 or just 0.1, right? Oh, all right, I'm going to get rid of all that. That's okay. So again, I'm just going to use 0.10. And you read account 2 and you come across 12%. So 0.12 or 0.12. Okay, good. 4 blanks to go. All right, I'm looking for time or interest. Well, I see interest, but it's a total. That's a total. That's not the interest from account 1. And it's not the interest from account 2. It's a total. I can't do that. What else do I have? Do I have anything? Oh, annual interest. How long of a time is annual? And that's 1 year. And therefore you know to put the time of 1. Now, that's not always 1. It might be 2, 3, 4, whatever. In this example, it's 1. All right, how are we going to get this interest? Well, again, that's why I want my equal signs there to remind you that the principal times the rate times the time is the interest. So let's multiply. The principal times the rate times the time. All right, when you do that, you get 0.1x, and we'll do the same thing for the y, 0.12y. Beautiful. Chart's done. All right, let's now go on to the equations. All right, and again, we're going to have 2 equations. We're going to have the equations are going to come from where? They're going to come from the columns with the variables. All right, let's start here with the principal. So I'm going to have a principal equation. I like to label what my equations are. Keeps everything straight, helps me when I go back to my chart. Is the principal equation a total or a comparison? That's the question. So I got to look back and see what it says about the principal. It says, if you look at the end of the first line, 100 less in another account. 100 less. When talking about the amount invested, it says a certain amount's invested in one rate and 100 less. That's a total or comparison. I hope you decide that's a comparison. Okay, what's the template for comparisons? First equals second. In this case, account 1 equaling account 2. Go back to your chart. Because I've labeled this as the principal equation, I can go back to my chart and see that the principal of account 1 is X, right? It's right here. Principal of account 1 is X, and the principal of account 2 is Y. Now, don't forget, I've got to come back to my comparison. All right, so let's read it. John invests so much in an account with a 10% interest rate and 100 less in the 12% account. 100 less in the, so this one is less. See, if I just do that, I'm going to be able to easily know how to make this 100 work. All right, the right-hand side is less. How do you make it equal? Add the amount it's less by. X equals Y plus 100. That's easy. If you'll label, because I know I'm talking about the principal equation. I know the right-hand side is the less one because it's account 2. And therefore, I know to add 100. That's it. All right, first equation. Let's go to our variable column for the second equation. All right, we have an interest equation. Interest equation. And it's going to be a total or a comparison. Look back at the original problem. Oh, total interest. 605. Well, that's easy. That's a total. How do you do totals? First plus the second equals the total. So account 1 plus the interest of account 2 will equal the total interest. Go back to your chart. What is the interest? See, I labeled it. It's an interest equation. What's the interest of account 1? 0.1x. What's the interest of account 2? 0.12y. What's the total? Back to the problem. Look up at the problem. $605.10. There we go. We've got our two equations. How are you going to solve it? Are you going to solve by substitution, or are you going to solve by elimination? You don't want a graph. You could use matrices. Okay. Again, you're looking at it. Well, the first equation is already solved for the x variable. That lends itself very, very easily to substitution. Now, let me mention something at this point. A lot of courses and texts advise you to multiply this equation by 100 to get rid of the decimals. To be honest with you, why? All right, you're going to have a calculator, it's Algebra 2, and you're going to multiply by 100. There's a possibility of a mistake there, and then you got all these big numbers. Just use the decimals. I don't think that's a big deal, but if multiplying by 100 floats your boat and that's what you got to do, then knock yourself out. Okay, so remember, we're going to sub in for x in the first equation. So what would you have? 0.1 times x plus 0.12y equals 605.1. Sub in the y plus 100. Okay? From there, it's just a factor of doing some math and finishing out the problem. Now, for time's sake, I'm not going to finish the problem. But remember, when you finish this thing, you're going to solve this first equation now for y. What is the y? It's the principal of account 2. So I don't know, maybe you end up with y being $1,000. How do you get x? Go back to your first equation. Y, sub it in, 1,000 plus 100. The other one must have been 1,100, right? So you're going to finish this off by solving for y, right? You're going to solve now this equation for y. Once you get y, you can get x, and you're going to answer the question. Okay? All right. We did a distance problem. We did an interest problem. Now I got to show you a digit problem. All right. Before I really get into this digit problem completely, let me remind you, or let me say a few things to you. Don't write this, I just want you to think. If I had the number 71, okay, it's a two-digit number. That's what we're dealing with here. That number 71. Okay, if I wanted to add up the two digits, I get an 8. An 8 isn't 71. How can I add the two digits and get 71? Well, I can do that if I multiply each digit by its value place. The 7 is in the tens column, and the 1 is in the ones or the units column. See, now I have 70 plus 1, and sure enough, that is our number 71. It's the way our number system goes. Okay? In pre-algebra right now, we're doing base 2 and stuff, and we're looking at all those aspects. But anyhow, that then leads us to what's up above. So this is important, and every single digit problem is set up this way. This never changes. Okay? That's always the same. Let t be the tens digit. Let u be the ones digit. They're just variables. Okay, t and u. All right, we're just using t. You don't want to use an o for the ones digit because you'll think it's a 0. All right, so t and u. All right. Now, what else? How would you do the original number? Well, just like I showed you, 10 times the digit in the tens place plus the units digit will allow you then to have the actual number. So that's always 10t plus u. Always. The original number always is. And a lot of times these problems have a reversed. What is the number with the digits reversed? Well, you have to swap out t and u, right? That's all. Okay. Those things don't change. I'm just telling you. Keyboard again. These things don't change. This is always the case for every digit problem. You set this up the exact same way. Okay. Now let's look to the problem. Usually in digit problems, one sentence is the first equation and the second sentence is the second. Now there's no chart. There's no formula, so there's no chart. Okay, so let's take a look at the first sentence. The sum of the digits of a two-digit number is 15. We've been doing these type of problems since pre-algebra. We've already named our variables, right? The tens digit is t, and the units digit is 1. This says to sum, keyword, right? Remember that? The sum of a two-digit number, what is an equal. Okay. What are you summing? The digits, the tens digit, the units digit, and what do you get? 15. There's the first equation. Came from the first sentence. Okay? Second equation. If the digits are reversed, the number formed is 9 less than the original. Okay, this is a comparison here. This is a comparison. So if the digits are reversed, the number formed is, there's my equal sign, is. So how do I say if the digits are reversed? Well, look back up. Remember, the digits reversed are always 10u plus t. 10u plus t. Okay? Look back up there. The number formed is 9 less than the original number. How do you say the original number? We'll look back up there. 10t plus u. Now again, I'm going to label these. This is the reversed number. This is the original number. Right? Go back to your problem, because remember, comparisons have to be made equal. If the digits are reversed, the number formed is 9 less. The number formed is the reversed digits. This is less. It's 9 less. So I have two choices. I can add 9 to the one that's less, or take 9 away from the one that is more. Those are my choices. Okay, I'm just going to, because I have room, I'm going to take 9 away from the one that's more. There are my two equations. That's it. Principles we've already learned. Okay, got to solve them, all right? Time's a wasting here. I got to get rolling. I'm going to use substitution again. Let's solve this for t. So let's move the u onto the other side. All right, that's that equation. Let's sub in t, 15 minus u for everywhere we see t in this second equation. 10u plus, got to put in t, equals 10 times, got to put in t, plus u minus 9. All right, sub in 15 minus u. 15 minus u. Again, pause the video if you need to, if I'm going too fast for you. All right, let's go ahead and now solve. All right, so summing up, we end up with 9u plus 15 equals 150. A negative 10u and a positive, it's a negative 9u minus the 9. Okay, let's get all our variables on one side. Let's add a positive 9u to both sides. So we'll get an 18u. Let's Add a negative 15 to the right, plus the negative 9 is negative 24, plus the 150 is a 126. All right, let's finish off by moving that 18. And when you take 126 and divide it by 18, you get 7. Okay, I just found out that the units digit is 7. So this number's like 97, 87, 77, 67, 57, 47, etc. Okay, well, let's finish it off. Remember, I always like to circle this because I'm going to use it again. T equals 15 minus, and what is u? 7. So therefore, t is 8. Ah, all right. Whoa, I don't know what that was. T is 8. Yeah. Beautiful. All right. So what is our number? So what is the final answer? The number is 87, right? Got a tens digit of 8 and a units digit of 7 and 87. Hey, we did it. All right. That's word problems. All right. Now this is on the net. If you have problems, come back to it. All right. The same principles over and over and over again. If you just take it a step at a time, you can get through it. You can do it. All right. That's it. Have a great night.